So our next concept is strain gauge. What do you mean by strain gauge? Okay, so uh, just to see the spelling, Gauge. Okay, strain gauge. So generally this is also a device which is used for measuring the mechanical surface strain. What do you mean by strain? Mechanical surface strain. So what is this meant for? So this is talking about the measurement of deformation. You remember we were talking about this in the basic requirements of a transducer. In the basic requirements of transducer, we are talking about the measurement of deformation. So deformation, when you are measuring this deformation, means like some element is compressed or it is tractioned or something we did to a material and we are using it to measure. Then in such case, when we applied some force and we made some mechanical strain, in that case a deformation happens. How to calculate this? So this is calculated by using a element called strain gauge. So the operation principle of this resistance strain gauge is as follows. Okay, so usually the basic concept, so we are talking about operational principle. Okay, so usually the basic concept of this electrical resistance is like hot resistance or copper or iron wire changes when subjected to tension or compression, right? Means when you're heating them up or when you're applying high voltages or something like that, when you're compressing them, then the wire resistance will be changed. So as a function of the strain increases with tension and reduces with compression. Usually sensitivity of the system is there, so it will affect the system sensitivity. Then obviously there is a change in resistance, and this change in resistance we should know. You got me what I'm saying? For example, there is a big circuit. We did something in the system. We were just using it with high voltages and we are making it run. At one point, system is little affected. It is affected, and at one point in the overall circuit, at one point some resistance is changed. So usually you kept a resistance as 15 ohms, but suddenly because of over operation of the system, this is changed. Now you want to know what is the change of it. Then you will make use of this bridge methods. Okay, like Wheatstone bridge method, like that. Okay, so now how are we going to calculate the resistance of this conductor? So usually resistance of the conductor is given as R is equals to rho L by A, right? Where rho is the resistivity of the system. L is the conductor, means the wire you have considered, and A is the area of the cross section of that conductor. So let me say this is the conductor, means this is the electric wire you have considered. So now you have applied a force on this, something has went wrong. So obviously there is a change and you want to know that value. Okay, so this is the length of the conductor and the cross section of area. So the cross section of area, I'm considering this as the cross section of area. Okay, so whenever there is effect like this, obviously the length will be changed to del L, L will be changed to del L, cross sectional area also will change, del A, and resistivity also change, del rho. So this is how these things were changing. So when these were changed, how are you going to calculate? Okay, so first let us differentiate equation 1 with respect to stress. Okay, so what happens? Usually our equation is R is equals to rho L by A. Now what I am saying with respect to stress means d by dp of R is equals to d by dp of rho L by E. So this is equals to rho by A. I am bringing it out. First I am checking for L. Okay, because 3 are separate elements. Nothing is a constant here. So first I am considering L. So rho by A I brought it out and I am writing it as dl by dp. Okay, then I am talking about rho, sensitivity. Then L by A comes out. So d rho by dp. Then area is in denominator 1 by A. 1 by A means obviously you will get, we are talking about A. So rho L will be out. Now this is like 1 by A. So obviously what happens? Minus 1 by A square minus 1 by A square dA by dp. This is the equation. Okay. So now let us divide both sides by r. Now what happens? 1 by r dr by dp is equals to, here what are we doing? 1 by r. That is the one we are dividing, right? So rho by A into 1 by r, isn't it? So that will be the equation, right? Into dl by dp. This is the first one I wrote here. Then second one. Okay, second one I am going to write it as L by A into 1 by r d rho by dp. Then third one I am going to write minus into plus will be minus rho L by A square into 1 by r into dA by dp. So these are our three equations, right? So now let us just solve it clearly. Okay. So now what happens to the equation? One by r dr by dp is equals to rho by A into 1 by r, right? Rho by A into 1 by r means rho by A into r means what? What is r? Rho L by A. So I am going to write the same. Rho L by A. Okay? Into dl by dp. Okay? Next. Plus L by A into 1 by rho by AN into d sensitivity by dp minus rho L by A square into 1 by rho L by A into dA by dp. So now the equation is 1 by r dr by dp is equals to rho by A cancel means 1 by L dl by dp plus, okay, so this is 1 by L, right? So 1 by L means L cancel, okay. A rho by A means A will go up, means A cancel means 1 by P d sensitivity by dp minus, okay, sorry, this is sensitivity, rho d rho by dp minus rho L by A cancel, here still A is left, so 1 by A dA by dp. Now see how is this equation? 1 by r dr by dp, 1 by L dl by dp, 1 by rho d rho by dp, 1 by A dA by dp. Okay, so this equation with the small variations I am going to write it as change of r. dr by dp I am writing it as change of r by r is equals to change of length by length plus change of sensitivity by sensitivity minus change of area of cross section by area of cross section. So this is my second equation. Okay. So now what I am going to say is, the conductor has some diameter and the area is given as area A is equals to pi by 4 d square. Okay. So you can write it as sigma A by sigma S is equals to 2 into pi by 4 d into sigma d by sigma S. Okay. So now dividing the both equations, divide by A on both sides. Okay. So now what happens? 1 by A, sigma A by sigma S is equals to 2 into pi by 4 d by pi by 4 d square into sigma A d by sigma S. Okay. So that is how we are writing, because A is what? Here 1 by A means pi by 4 d square. Pi by 4 cancel, d square cancel. So what are we saying? Change of A. This is called change of A, right? Change of A by A is equals to 2 is there. 2 into change of D by D. Okay. So the area of cross section is nothing but change of with a double diameter. If area is changed, means the diameter is a double changed, means it is becoming double. Okay. So now the change in diameter of wire can be related with the change in of its length. So usually change in the diameter is given as minus mu, means the Poisson's ratio of the wire, okay, by del L by L. So therefore I can say AB. Substitute B in A. Therefore del A by A is equals to minus 2 mu del L by L. If area is changed, means this much of length is changed. Okay. So this is written as equation 3. So substitute equation 3. So now let us substitute our equation 3. Substitute equation 3 in equation 2. Then it will become del R by R is equals to del L by L plus del sensitivity by sensitivity minus, right, minus del A by A. But del A by del A is what? Minus T mu del L by L. Minus minus can be written as plus. So del R by R is equals to del L by L plus del sensitivity by sensitivity plus T mu del L by L. Okay. So let me make del L by L common. So this is equals to del L by L. If I take it as common, 1 plus del rho by rho by del L by L plus 2 mu is equals to del R by R. So let me bring this side. So del R by R by del L by L is equals to 1 plus T mu plus del rho by rho by del L by L. Okay. Clear? So now here the gauge factor, the strain gauge, right? The gauge factor. So the strain gauge, we are having a gauge factor called a G, which is considered as del R by R by del L by L, which is this. So this one I am going to term it as G. Okay, I am going to term it as G. So therefore, we can say that the equation G, the gauge factor, means the strain gauge factor, G is equals to 1 plus T mu plus change in the resistivity by change in the length. So this is a strain gauge method. Okay.